Hello and welcome. It's your main math man, Mr. Lyons here. Hope all is well. And today we are on page 10 of our Unit 4 packet, and we are discovering and we're using a rule to multiply exponential expressions. Take a look at this first box here. We are multiplying exponential expressions. We have 2 to the third power and times 2 to the fourth power, right? Now, expanded form. We did this just the other day. Expanded form. How are we going to expand this? Let's take a look at this first expression here. This is going to be what? The base is 2, and I'm multiplying 2 as a factor how many times? 3 times, right? 2 to the third power, right? 2 times 2 times 2. Times another exponential expression. Go ahead and see if you can expand this on your own as well, right here. This is going to be what? Times 2 times 2 times 2 times 2, because we have 2 as a base and 4 as the exponent. Remember, exponents are directives. They're saying, hey, take this factor and multiply it by itself this many times. That's what exponents are. Standard form. Standard form looks like, well, how do you multiply this? You know what standard form is, right? Let's do some mental math. If you need a calculator, you should have it by you. 2 times 2 is 4, times 2 is 8, right? And then 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is, that's right, 128 is this is expanded form, right? 2 times 2 times 2 is 8, we said, and then 2 times 2 is 4. 2 times 2 is 4. 4 to 6 times 16. 8 times 16 is 128. Check that. Peep the mental math. I'm hooking you up right now. All right? So standard form is when you multiply all those 2's together, because we have the same base here, right? An exponential form, how would this look like an exponential form, right? Well, we know our base is what? 2. How many times are we using 2 as a factor here? 3 times? 4 times? We have a total of how many bases of 2's? That's right, 7 times, right? So this is what that looks like in standard form, but in exponential form, 2 to the third power times 2 to the fourth power is 2 to the seventh power. We have 7 2's as the base, right? And when it says conclusion, let's think, what did we notice here? For first conclusion, I want you to think about is 2 to the third times 2 to the fourth. What did we do with our exponents to get this number 7? That's one of the first conclusions I want you to think about. And then the second conclusion is, what do you notice that these exponential expressions have in common? What do you notice that they have in common, right? So first we're trying to figure out how did I get the 7? And what do these things have in common, all right? Let's think about that for a second. Go over here. It's going to look a little different over here. Let's expand this. Go ahead and see if you can expand this on your own. As always, if you feel comfortable, pause the video. Try to do it on your own. 3 to the second power is 3 times 3, 2 bases of 3's, times 2 to the third power, that's times 2 times 2 times 2. Standard form, that's 3 times 3, which is 9. 2 times 2 is 4, times 2 is 8. Standard form is going to give me what? 72. In exponential form, though, see what we did over here in exponential form. Can we do the same thing over here? Well, let's think about that. What do you notice is different? Again, this is going to be what? 3 to the second power times 2 to the third power. Well, what I did over here didn't really work over here. So let's think about this conclusion as well, right? What could we not do on this side that we were able to do on this side to get 7? Why do you think that is? What do you notice is different about these expressions compared to these expressions, right? Go ahead and try to come up with those conclusions. What do you notice that we were able to get the 7 over here that we couldn't get, like what, to combine these over here? And what do you notice is the same and different about these exponential expressions? Go ahead and write those conclusions in, and I'll check you in the next video.